telling you that you could take the derivative twice. But also, if they tell you that it's differentiable, it implies it's a continuous function. Do you agree with that statement? So it's important for things to be continuous for us. And so that's part of why they tell us this. They also tell us it's strictly increasing. The graph of R and a table of selected values from the time 0 to 90 minutes are shown above. And notice I only put C and D on this because we couldn't have done the other ones. But it says approximate the value of 0 to 90 RT using a left Riemann sum with 5 subintervals indicated by the data in the table. Is this numerical approximation less than the actual value? Explain your reasoning. The one on the homework I gave you yesterday asked you to do a midpoint Riemann sum, and it actually worked out that each interval was the same amount. But this one doesn't. They want you to use a left Riemann sum with 5 subintervals. That means 5 rectangles. And you could use the graph or you could use the table here. But do you agree that this would be one rectangle from 0 to 30? Then from 30 to 40 would be 2, 3, 4, 5. That kind of looks crazy. What if I do it out here from where these dots are? This would be one rectangle. And then the next one I know is from here would be the second rectangle. And then from here would be the third rectangle, fourth rectangle, fifth rectangle. And we have to use the points they give us because we don't have an equation to make our own rectangles.
Is that a right graph?
Oh yeah, I totally just drew right, didn't I?
Would be the other.
Left is this side. So it should be like this way. Fail. Sort of, roughly speaking. And again, up until this point when we've done Riemann sums, we've always made the intervals equal width. But they don't have to be equal width because those are some terrible rectangles I drew. Because we can do whatever width we want and just do the area of each rectangle. And just from looking at that picture, before we actually even find it, it says, is this less than the value of the integral or greater than? And looking at that picture, is this going to underestimate or overestimate? Yeah, and we haven't really talked about this too much, but with Riemann sums, it's all about whether the function is increasing or decreasing. And because this function is increasing, a left Riemann sum is always going to underestimate. But you could just draw the picture. Notice it says explain your reasoning. They want you to say it underestimates because the function is increasing. If you say it underestimates because the rectangles are under the curve, they're not going to give you points for that. That's true. It underestimates because the rectangles are under the curve, but they want you to say because it's increasing. So anytime they say explain your reasoning, they want you to talk about calculus. They want you to talk about increasing, decreasing, derivatives, okay? But if the function was decreasing, a left, you see what I'm saying? So if you said because it's a left Riemann sum and it's increasing, you really have to say those two things together. Because I draw the picture to help me remember because it changes depending on if it's increasing or decreasing and whether it's left, right, or midpoint. But that's what they really want you to say on this. So it's less than because R of t is increasing. And to actually find the value of this, we can just set up our rectangles. So we have to take the width times the height. Or length times height. So the length of this is 30, and the height is the left endpoint, which I really would have caught eventually. But the left endpoint, which you can look at the graph, or you can just look at the table, that the first height would be 20. When we did these before, when they were equal widths, we just pulled that width out front, right? But we can't do that because these are different. So the second one is just 30 to 40. So that would be a width of 10, and the height would now be 30 because it's the second one. The next one goes, I can't even look at my graph because I've drawn it so bad. But the next one goes from 40 to 50, which is also a width of 10. and the height is 40. The next one goes from 50 to 70, which is a width of 20, and then it would be a height of 55. And the last one goes from 70 to 90, which is also 20, with a height of 65. And I always remember, if it's a left Riemann sum, I start with the left endpoint, and I don't use the last one because it's not a height of anything. If it was a right Riemann sum, I would skip the first one and use that first right endpoint and go all the way to the end. So that's why I was kind of checking those off as I went. But I gave you this just to show you that we could do trapezoids with different widths, and we can also do Riemann sums. I believe this is a no calculator question, which means that, again, you could leave your answer like that and you would get credit for it. I like to tell you this because I'm trying to get you in that mode of, like, don't miss it because you make an arithmetic mistake. But obviously you have a calculator, or this isn't terrible math to do, right? Maybe this should be a calculator question. This is kind of, I don't know. We'll just go with it. Anybody got an answer?
So it says we see approximate value. This is actually exact value.
It's not the exact value
Okay.
because we're using these rectangles, right? So we're missing that little section there. We don't have an equation, so it's the best we can do right now using these rectangles. But that's why it says approximate. I got 3,700. Did you get 3,700? Are you already there? Sorry. All right, look at the next part. They like to ask you the meaning of things. It says, for 0 to 90 minutes, explain the meaning of the integral from 0 to b of r of t in terms of fuel consumption for the plane, and then explain the meaning of 1 over b from 0 to b of r of t in terms of fuel consumption for the plane. Indicate units of measure. To me, the units of measure sometimes are the trickiest. But first of all, don't think about the problem for a minute. Just think about what we know about integrals. What's the difference between this and then putting the 1 over b in front? Yeah, this is a total, this is average, right? So because that's the average value, and I hope after doing the ones yesterday and the ones on your homework, maybe you kind of are seeing that now because it shows up a lot. What they want you to do is explain it in terms of fuel consumption, which means they don't want you to say, this is the total value, this is the average value. They want you to talk about fuel consumption, they want you to talk about gallons per minute, they want you to use those kind of words, right? So, here's what I said. The integral from 0 to b of r of t dt is the total amount of fuel consumption in gallons. Okay, I didn't word this well. Consumed from 0 to b minutes. That's some terrible writing. And when I say the AP exam makes you write, this is kind of writing that they do. They're not going to make you write an essay, but they're going to make you explain your answer. So this gives you the total amount of fuel consumptions in gallons consumed from 0 to b minutes. So when we did this from 0 to 90 minutes, we were finding the total gallons consumed from 0 to 90 minutes. And they really want you to use those words, like relate it back to the problem. So now think about if we throw the 1 over b. We definitely could say it's the average amount consumed, right? But if the units on this is minutes, that's not right. The units on this is gallons. How many gallons were used from 0 to b minutes? What are my units going to be when I divide by b out here now? If this is gallons, what's going to happen now when I divide by b? My answer. The average amount consumed in gallons per minute, because we're dividing by V minutes out front. And so when you throw in the average, it changes from just total gallons consumed to average gallons per minute. And so I always say, think about the units on B, or think about the units on this as you're doing this. So, and I just wrote this, from 1 over B, integral from 0 to B of R of T is the average, I wrote average value, I don't know if this, this is what I wrote. Average value of the rate of fuel consumed in gallons per minute from 0 to B minutes. And we'll practice more with this. I'd just like you to see these, especially before we have our first exam next week, to kind of see the things that you might be asked. I can definitely tell you that one of the 3 questions I'm going to ask you next week is going to have to do with something like these questions. I'm going to ask you to do a Riemann sum or a trapezoidal sum from a graph or a picture. I'm going to ask you to do this type of stuff. I'm not going to tell you what the other ones are because you don't always know in the AP exam what they're going to be, but I'll give you one of them is going to come from this kind of stuff here. All right? So I felt like the first free response question I gave you yesterday maybe wasn't so bad. Is that true or not true? And when I was telling, I don't even know who I was telling at this point, but I like to give you these for you to see that the reason that I feel like I can get you all to do well on this exam is because the same types of questions show up, they just change what they're talking about. Instead of talking about the rate of fuel consumption, or instead of talking about people standing in line to buy tickets, they can give you a question that says, a zoo sponsored a contest to name a baby elephant. Elephant? Blah, blah, blah. They're from 0 to 8. Same types of question. And again, look at part A. Use the data to approximate the rate in hundreds of entries per hour at which they were being deposited at t equals 6. Show the computations. That's just like part A that we did yesterday. If they ask you to approximate the rate, they're asking you for the derivative, but you don't know the derivative at 6 seconds. But what you do know is you can do the slope between 5 and 7 seconds, right? Definitely something you're going to see again. Here, let me find my answer so I can make sure that you all agree on this. 4 entries per hour for part A. 400 entries per hour. That's 1 point on the exam. Part B says use a trapezoidal sum with 4 subintervals given by the table to approximate 1 over 8 from 0 to 8 e of t. And then, using correct units, explain the meaning in terms of the number of entries. Again, I hope that now that you see that number up front, automatically in your head, you're thinking average value. And from 0 to 8, it says do 4 of them. This really does already break it up into 4, right? 0 to 2 to 5 to 7 to 8. They're just not equal ones. And so I'll just tell you the answer, and then you can tell me if you agree or disagree. I got the total answer with the 1 over 8, 10.688. What? Well, it's fine. So you got 10.687 something? That's fine. The AP exam, 3 is what they count, and they'll count the first, if you write 7 decimals, they count the first 3. So they actually would count 10.687 or 10.688 as your answer on that. And if you didn't get that, I have my work. I'll show you to you later. And then explain the meaning. I said this means the average number of hundreds of entries in the box from noon to 8 p.m. Something like that. If you just said the average number of entries in the box, you didn't say hundreds of entries, I think they would count that. But this is in hundreds. What they don't want you to say is this shows you the average value from 0 to 8. That's true, but that's just straight calculus talk, and they want you to take that calculus and apply it to the actual problem. So I said it's the average number of entries in the box from noon, that's 0, to 8 p.m. Something to that effect. Obviously, they would count some of that other stuff. That's the fun part about grading these, is trying to figure out what to count. On the second one, A and B are really the part that I feel like you should be able to This one, I feel like they kind of give you the answer later on. Like, look on part A. It says, write an integral expression to show the average radius. And then look at part C. They give you an integral. Guess what? It kind of, like, they're giving you the answer to part A, kind of. But I think this is a really tricky question, and I missed this the first time I did it, because I said, oh, if this is b of x, and I want to write an integral from 0 to 360, I said the answer is the integral from 0 to 360 of b of x d of x. Show an integral that represents the average radius of the blood vessel. But I missed it because I didn't read that word very well. It wants you to find the average radius, and this b of x is the diameter. And I actually totally screwed up because it's average, right? Average means 1 over 360. I really did put that eventually. Just so you know, you have to divide by 2 there, and you have to put the 2 inside the integral or outside because you can factor it out.
I'm in line.
Talk about this later. Here's what I want you to do for homework, okay?
Meadows,
If
the
you didn't do part B on this one, try part B.
Tyler Newman,
And I
Bryce
want you to
Hospital,
start your
report to
review as much as
guidance.
possible because
Tyler
Monday,
Newman and
I'm going
Bryce
to talk about
Hospital,
the test for
report to
like a
guidance.
short time, and then the rest is going to be me answering your